We're given a quadratic function with a restricted domain. So here's a quadratic function, but some of it's going to be cut off. I'm not entirely sure where yet. We're asked for the range, and that means I need to try and find the minimum and see if it's in the domain. So to do this, we can either differentiate or complete the square. I tend to just complete the square for quadratics. So x minus 1 all squared, and then minus 1 plus 6 will become plus 5. That tells me that the minimum is at 1, 5. So in fact, the graph is going to look a little bit like this, and maybe down here. So the origin here. So I've cut off all the parabola to the left, so it's going to go down, hit a minimum and back up, and therefore it's going to be all the values including or greater than the minimum. Hence f of x will be greater or equal to 5. We're given another function now. I'm just going to extend the square roots because it will be over the whole thing. It's also got a restricted domain of x is greater or equal to 2. Then we're asked to find g of f of x. So this becomes g of x squared minus 2x plus 6, which I could write as in completed square form. So it's g of x minus 1 squared plus 5. I think I'm going to do that. So then I get 3 plus the square root. I replace all my x's by x minus 1 squared plus 5. Then I add 4 to it, so it's x minus 1 squared plus 9. And that's going to be my final answer. Okay, I could expand the quadratic, but I think that's okay as we've got it. Finally, we're asked to find the domain and range of g of f. So for this to exist, the domain has to be the domain of f of x, in fact. Therefore, x will be greater or equal to 0. Now let's just take a look at what's happening. We've got these different x values greater or equal to 0, and then they're mapping onto f of x, and out of that we're going to get greater or equal to 5. Now that's okay because these become the x values in my new function, although this function here rather than this one. And so we need that x is greater or equal to 2, which we have because it's greater or equal to 5. So basically the range of f of x is contained within the domain of g of x, so we're okay. It's just something that you need to check because otherwise the function doesn't exist. And then out of this we're going to get some sort of range. So we can now still focus on this function here, and we can take a look at the um, have a look at the function and think what the minimum value is. So because it's still a quadratic, it's going to go, and we've got x is greater or equal to 0, then like this part is still going to look a bit like this. It's going to go down and then come back up. So I'm interested in the minimum part, which is the minimum point, which is when x is 1 again. And therefore for the lowest value, I'm going to get 3 plus root 9, which is 6. And that is going to be our lowest point. Therefore, g of f of x has to be greater or equal to 6. If you prefer, then you could take the greater or equal to 5 and say that is our new x values for this function. And then the smallest x value, like this is now an increasing function, it's a square root. So I don't know, it's going to look a bit like this. So the lowest point is going to be when we get 5. Then it's going to be 3 plus root 9 that way, which is also 6. So those two ways to think about it, but the composite function exists, no problem. We've kind of gone into detail on it, but that is the domain is going to be x is greater or equal to 0. The range is going to be g of f of x is greater or equal to 6. Well done.